Hello friends, very good morning. Myself Dr. M.H. Annaiah, and in today's video we are going to work out a problem on the selection of SKF ball bearing when the load the bearing has to withstand as specified, and the diameter of the shaft is also given to us. So friends, let us see how to solve this problem. And in today's video, the question reads like this. Select suitable SKF deep groove ball bearing to sustain radial load of 2 kN and axial load of 3 kN. The service imposes medium shock and the bearing will be in use for 2 years at 10 hours per day. And based on the strength, the shaft diameter is given to be 60 mm. So you have to go through the problem completely and go ahead with the solution. Friends, whether the diameter of the shaft is given to us or not given to us, the first step we do is we find out the LN, the life of the bearing expected or the life of the bearing required. And you can say here, friends, to find step number one, to find LN. Friends, LN means the life of the bearing in millions of revolutions, MOR. Friends, here he says in the question, the bearing will be in use for 2 years. So I will take 2 years. At 10 hours per day, at 10 hours per day, and RPM of the shaft is given to be 1000. So you have to write like this. What is the number of years it has to be in use, how many hours, etc. Then friends, I am going to convert these years into 365 days, and this is into 10 hours per day. So friends, this will give you total days and total hours it will give you. And if you multiply by 60, it will give you how many minutes it will be there in use. And friends, if you multiply it by 1000 RPM, this is minute revolutions, this is RPM, and friends, you are going to get revolutions there. So this I am going to divide by 10 to the power of 6 to get LN in so many millions of revolution. MOR means millions of revolution. See, once again I will explain. The number of years given is 2 years. So I converted it into days. It will be 10 hours per day. So it will become total number of hours. Hours is converted into minutes by multiplying by 60. Further, this is multiplied by 1000, that is the speed of the shaft, to convert that to revolutions. Divide by 10 to the power of 6 will give you the answer in millions of revolutions. Friends, if you simplify, this works out to 438 millions of revolution. The meaning of this is that when you are using this for 2 years at 10 hours per day, it has to make 438 millions of revolution before it is discarded from service or before the bearing is changed. That is what it means. So calculation of this is very important, and we should check the calculation twice, because generally we go wrong in putting these places 10 to the power of 6 or whatever it may be. You have to check it twice before you go to the second step. Friends, this first step is a common step for all the problems in ball bearing, whether the diameter is given to us or not given to us. Next comes, friends, step number 2, in which we are going to find out, based on the diameter of the shaft, what are the shaft sizes or bearings available, And based on that, we are going to check bearing number 1 to 3, that is to say 60 millimeter dia is specified in the question. So we are going to try 60 BCO2, that's called light series, 60 BCO3 medium series, 60 BCO4, that is heavy series. So after every step, we calculate the life of the bearing, that particular bearing. Say 60 BCO2, what life it will have. We are going to have a comparison with the life of bearing expected, that is 438. So we keep on doing till we get the life of that particular bearing out of these three, which has got a life of 438 or more. It should never be lesser than that. So in the second step, I am going to say selection of bearing. Selection of bearing. It is SKF bearing. So friends, in the selection of bearing, the diameter of the shaft is specified as 60 mm. We use for 2 years. The service imposed of that shaft, and based on the shaft diameter may be taken as 60 mm. I have underlined. So since diameter is known based on strength, as B equal to 60 mm, comma, we try the following bearings. Namely 60 BCO2, which is also called as SKF 6212 bearing, 60 BCO3, the medium series, that is SKF 6312, and finally 60 BCO4 bearing, which is represented as SKF 6412. Like this, friends, we are going to try all these in order. Find out the first one, the life of bearing. Get what is the answer for the life it will have. If the value is equal to or lesser than 438, you cannot select this. So you have to go to second step, third step, etc. So we will have the first trial made using 60 BC O2 bearing. We will say trial number one. Trial number one. We will say try 60 BC O2 bearing. That is a light series. So for this 60 BC O2 bearing, we have to refer to the data handbook and obtain the two terms called two loads, that is C0 and C. C0 is called the static capacity of bearing, and this value works out to or is available as 32,500 Newton, 32,500 Newton, and C, the dynamic capacity or dynamic load, that is given as 47,500 Newton. Friends, you may ask me why we have to take this. Because we have for this bearing, for the ball bearing, Ln is equal to C by P to the power of 3. So here the C is the dynamic capacity, and if you are able to find out the value of P, that is the equivalent of radial and axial loads, you can substitute and find out the life of the bearing. Friends, here you have got the value of C as 47,500. I have to find out P, to calculate ln for this bearing. So for P, friends, we have the formula P is equal to XFR plus Y times FA is given in the machine design data handbook. And friends, here this has to be multiplied by a term called service factor CS. I have already explained in one of my previous videos that CS depends on the type of service the bearing is subjected to. If it is light shock, we will have to multiply it by 1.25. If it is medium shock, this has to be 1.5. So in the question it is specified as medium shock, and hence I have to use the value 1.5 here. So friends, here this is X times FR is the radial load. The radial load is given to be 2 kilonewton, that is X into 2000, 2 kilonewtons 2000 Newton plus Y times FA. Y times FA is the axial load, which is also called as the thrust load, that is 3 kilonewton or 3000 Y into FA multiplied by the whole thing multiplied by CS, service factor. We take it as 1.5 because the bearing is subjected to medium shock. Friends, to get the value of P, we need to know what is X and Y. So when you are able to find out X and Y from the table, we will be able to find out the value of P, and hence the value of the life of that particular bearing in millions of revolution. So we go ahead with the calculation of X and Y. Friends, these constants or factors X and Y depends on the FA over C naught ratio. So we will say here, because in the table, if you refer to data handbook, there is a column like this. In one column it says what is FA over C naught, and then is comparing with E. Then if E is greater than, so there are some terms like this. The value of X comma Y are available from here. So we have to find out what is FA over C naught. We know FA, C naught we have taken from the table, and friends, we can say for the given bearing, for the given bearing, FA over C naught. FA is the axial load is 3000 divided by C naught is 32,500, and friends, this works out to 0.084, for which we have this constant E is equal to 0.28. This is available from the table. So find out the ratio of FAC naught, find out the corresponding value of E. Next, we also find out what is FA over FR ratio for the given bearing, because we have to compare this with this E to get X and Y. So FA over FR for the given bearing is, FA is 2000, the axial load is 3000, 3 kilonewton, divided by radial load is 2 kilonewton or 2000 Newton. So this goes out to 1.5. Again I will explain, friends. To find out X and Y, we have to find out what is FA over C naught. FA value is given in the question. C naught value is obtained from the table of these ball bearings. For the bearing 60 BCO2 is given. So you have to get the value and then find out what is the value of E corresponding to this from the same table. Also, you have to find out this FA over FR for the given bearing. Compare this value with E. So FA over FR we have got 1.5. On comparison with E, comma, we find FA over FR is equal to 1.5. When you compare with E, it is greater than E because 1.5 is greater than 0.28. Friends, then the same tabular column is given. Whenever the ratio of FA over FR is greater than E, then X is equal to 0.56 and Y equal to 1.55. Again, these values of X and Y are obtained from the same table what we are referring to. So friends, we have the value of X and Y, we know FA, FR, etc. So what we do, we make the substitution in the formula for P. So P is equal to XFR, X is 0.56, FR, radial load 2000 plus Y times FA, Y is 1.55, FA is 3 kilonewton given in the question, multiplied by the service factor 1.5 because the bearing is subjected to medium shock, and hence friends you get this value of P as 8655, 8655 Newton. So friends, we have the value of P, we have the value of C, the dynamic capacity of the bearing, and use the formula Ln is equal to C by P to the power of 3 and obtain what is the life of this bearing 60 BCO2. Therefore, from Ln equal to C by P to the power of 3, comma, we have Ln equal to C value is 47,500 obtained from the table, divided by P value is 8675, that is raised to the power of 3. Friends, if you calculate, this works out to 438, sorry, this 165.2, 165.2, the units are millions of revolution. It means for the given load condition, for the number of rotations given, for this 60 BC O2 bearing, if you are using for 2 years at 10 hours per day, it will make 165.2 millions of revolution. So, but we need to have minimum 438 millions of revolution as per the first step in the calculation. So, this value of Ln is far lesser than Ln required. What is the value of Ln required? That is nothing but 438 MOR. That is to say, this bearing in the period of 2 years will be making only 165.2 millions of revolution when it has to be discarded, and hence since the required life of bearing is to be 438 point something minimum, we cannot take this, and we will say this bearing is not suitable, for the given application, not suitable. So when it is not suitable, we have to make a second trial on the same procedure and find out what the life second bearing will have. So we are going to have a second trial made, trial number 2. So 60 BC O2 we tried and we got a value very less than the required value of Ln, and hence you will have to go in for trial number 2. We repeat the same procedure as we have done for 60 BCO2. Now friends, for this 60 BCO3 bearing, that is a medium series ball bearing, we have once again go ahead with the selection of C and C naught. For this bearing, the value of C will be 52,000. The C naught is 52,000 Newton, and this dynamic capacity is 81,000 Newton. These are the values obtained for this bearing from the chapter ball bearings. And friends, this is the value you have got. Next, what do? We find out what is FA over C naught. That is to find the value of X and Y, as you know in the first step. So FA over C naught. FA is 3000 Newton axial load divided by C naught is 52,000 Newton, and this works out to friend 0.053. 0.053 is the value of FA over C naught. Friends, this value of FA over C naught may not be available because in the same value there are about 10 values given there, 8 to 10 values, different values of FA over C naught. And the value nearest to this, it could be higher or slightly lower than that, doesn't matter. I will say nearest to table value or nearest value available in table is FA over C naught is equal to 0.056, the nearest value. The difference is too less. For which we have E equal to 0.26, because you have to make a comparison of FA over FR with E to find what is X and Y. Now friends, we have the value of FA over C naught, for which you have got E is equal to 0.26. Now friends, you will have to have a comparison of this value of E with FA over FR. And remember friends, FA over FR is a constant for a given bearing. Right now, FA over FR is 3000 divided by 2000, which is equal to 1.5. Ratio is 1.5. Now to get X and Y, you have to compare this with E. So comparing FA over FR with E, the constant E, we find FA over FR is equal to 1.5 is greater than E, which is equal to 0.26. And hence, whenever it is greater than, I told you, X is equal to 0.56, and corresponding to that in the Y column, you find 1.71 is the value of the Y. Friends, we know X, you know Y, you know the values of the FR and FA, and hence you will be able to find out what is the value of P. Therefore, P is equal to XFR plus YFA into CS becomes, we'll make the substitution. X is 0.56, radial load is 2000 Newton plus Y is 1.71, FA is 3000 multiplied by service factor. Service is medium sharp, so it is 1.5. This friends on simplification works out to 9375. 9375 Newton. It's a load. So this much of load, the equivalent load P you get, including this service condition. Now friends, finally we will substitute in the formula. Ln is equal to C by P to the power of 3 and find out what is Ln. Substituting in Ln equal to C by P to the power of 3, we get Ln equal to C value is the value is 81,000 Newton divided by P, which you got as 9375, that is to the power of 3. And this works out to 666.71. 666.71 is a life of bearing. It is MOR, millions of revolution. So what is the meaning of this? We are analyzing the second bearing, that is 60 BCO2, O3 sorry, and it will have a life of 666.71 millions of revolution. And what we want is minimum of 438 millions of revolution as per the calculation we have made in first step. And hence, friends, you can make a comment. This is so many MR, which is far greater than Ln required. That is calculated in the first step, which is equal to 438 millions of revolution. Hence, what do we do when it is satisfying the requirement? We say select bearing 60 BCO3. This you have to select, and after getting the right bearing, you have to write a simple sketch of that bearing. Directly copy from the handbook and write down the different values like this. So friends, you have this bearing. It will have a fillet at the ends, and you will have the shaft diameter, which is represented as small d. That small d is 68 given in the question. The outside diameter is capital D, which works out to 130. This is again copying from the handbook. Diameter is given to be 60. I will write down here by 60. That is given, and we will have this simple sketch of this ball bearing. And friends, you will have what is called width of the bearing, capital B, and the fillet radius R at all the four corners. Friends, here this B is given to be 31 millimeter, and R, the fillet radius, will be 2.1 millimeter. Sorry, 2.1 millimeter. And friends, this is how we select the ball bearing when the loads the bearing has to sustain and the service conditions are given to us. Friends, I hope the presentation was interesting. Please go through the complete video without fail, and if you like the video, please share with all your friends without fail. I thank you very much. Have a wonderful day.